Hi, I'm going to talk today about one of the options that you have in the program JMP to get an idea of how you might need to sample for a project that you're starting. And this option is called DOE, or Design of Experiments. And it can be really useful. There are a lot of options. You can find it as a drop-down menu in JMP. You see I'm selecting it here. And you have a lot of options with this menu. We are going to use what we call the sample size and power option to do some simple calculations that will help you get an idea of what your sampling might need to be for a project. Now, before you use this, I recommend that you go out and make a few observations, spend a few hours observing the objects you're trying to observe for your study, and collect some basic numbers, because you'll want to plug something somewhat realistic into this to get an idea of what you need to do. So we're selecting this option called sample size and power. And this is a type of analysis that will give you an idea of your ability to reject a null hypothesis. And so that is what power stands for. It's this probability that you're rejecting a null hypothesis, that you have collected enough sample sizes to reject a null hypothesis. And so power numbers can be important when you conduct a study and you fail to reject a null. Sometimes you might be rejecting that null or failing to reject that null because indeed there just wasn't a pattern. The pattern wasn't there. We thought we were observing a pattern that was two variables related to each other, but that just wasn't the case. If you fail to reject that null hypothesis when there really isn't a pattern, that's a good thing. We don't want to be saying something is true when it's not. However, a lot of times people are failing to reject a null because they don't have enough samples. They haven't collected enough samples. And that might be because they haven't spent enough time making their observations. It might also be that the difference is so small that it would take them years and years to collect enough samples. And so we want to get an idea of how realistic our project is going to be by entering some realistic numbers. And so you'll see when you open this menu, you have some tests that you can choose from. And the first several weeks of this program, you're going to be learning to do analysis of variance. You're going to be learning about the chi-squared test and some other very useful tests in ecology. And so the example that we've been working through for the study design lectures has been an example of what I would call K-sample means. That's a type of analysis that you're going to be learning called ANOVA, or analysis of variance. And so we are comparing the means from several samples, from more than 2 samples. And so you see there is also an option if you're setting up a study where you're basically going to compare 2 environments, or the means, the averages of some value in 2 environments, you can use that. We're going to use the example of Pacific wrens and comparing their abundances in different ages of forests that have been logged. You can also look at proportions. The 1 and 2 sample proportions test could be used for something like a chi-squared. You have to modify a little bit your observed and expected values to apply it to use these proportion tests. But people that are going to do something like a chi-squared, we can show you how to use this to estimate your sample size. For a lot of the examples that you would be dealing with, you can form your question for this purpose into something that's like a K-sample means. That's what we're going to use in this example. So when you select K-sample means, you'll see this window pop up, and this window has a few places where you fill in information. So the first thing you'll see is testing if there are differences among K-means. So you have to enter some information to tell the program what you want to, how significant the data have to be. And so that first value here is the alpha value, and in JMP, the default alpha is 0.05. And the alpha is the critical value. So this is the value at which we will reject a null hypothesis. And in most ecological studies, a p of 0.05 or smaller is when you reject a null hypothesis. So we're going to keep that. That default is just fine. For standard deviation, you need to be entering a value that's somewhat near reality for the study organisms you're looking at. That's where going out and doing some brief observations and getting some numbers, or using an example data set that you get from us. We will be providing sample data sets in our statistics labs, or from online sources. There's lots of online sources of data. Or from the literature, you might start to read about a topic that you're interested in, and you'll see numbers of what you're interested in reported with standard deviations or 95% confidence intervals, or some estimate that could give you an idea of variation around a mean. For the Pacific Rim example, a reasonable standard deviation is going to be 1. We're going to be looking at numbers of individuals per hectare, which is density, and a standard deviation of 1 is not out of the ordinary for when you're surveying Pacific Rims. Now the next set of blanks that you can fill in are your groups. And so you can have anywhere from 3 to, I don't know, this might be 10 or so groups. Now the more groups you add, the more samples you have to collect. In this example, the Pacific Rim example, we worked through a concept where we would be looking at 3 age groups of forests. So one forest that's very young, logged, say 5 years ago, one that was logged 20 years ago, that would be in the middle age range, and then older forests, 80 or plus years old, that look more like old growth forest. And so we're going to go on that continuum, think about those different groups. Now, previous research has suggested that in really excellent quality habitat, you can find Pacific Rim densities of about 2 individuals per hectare during the breeding season. So what that means is basically a breeding pair is defending a territory of about 1 hectare in size. And so that's our optimal. So I'm going to enter in 2 because that's what I've understood from the literature. And in poor quality habitat, you'll find that the wrens have to defend a much larger territory. They might defend a territory of up to 2 hectares, a breeding pair. And so that would actually, if we were to scale that back down to 1 hectare, you're looking at, in poor quality habitat, about 1 individual per hectare. And then we could just pick a medium value for intermediate habitat. So when we do this, we're going to have these values, and we're going to want to know what our sample size would be. So if we go out and we want to be sure that we have collected enough data to reject a null and we get numbers like this, then we want to have a confidence that we're rejecting the null when it should be rejected. And a general rule of thumb for power, and power is a value that's expressed as a ratio between, or proportion between 0 and 1. 1 being, I have 100% confidence that I'm rejecting the null hypothesis when it should be. That's a sort of unrealistic upper limit standard to set on your data, but you want to be pretty confident. So let's just say we want to be 90% sure that we are rejecting the null when it should be. So I'm going to put in a power of 0.9. Okay, and if I want to be really confident, put in a power of 0.9, I can now hit continue. And this program, given the metrics that I put in up above, my alpha, my standard deviation, the differences I'm expecting to see in the different habitats, my power, it's saying that I need a sample size of about 80 to detect those differences. And so what that means is 80 total samples, and 80 divided by 3. So that's actually a relatively small sample size needed to detect the difference if it really exists. Now, something useful to know, this gives me a good idea. Okay, I'm going to need to go out and conduct 80 point count surveys. They need to be roughly evenly divided between the habitat types. So about 26, 27 or so surveys per habitat. I can do that. I start to come back with my numbers. I go into these habitats, I'm surveying the birds, and I'm not finding exactly what I'm predicting. And so it's useful to think about this even before you start your surveys, because often the unpredicted happens. Sometimes what we get are differences that are well beyond what we expect. Although in this example, I'm not expecting to find higher densities than 2 or much lower densities than 1, because much lower densities than 1, a breeding pair actually can't effectively defend a territory. And it just hasn't been found that you can find birds packed in much tighter than 2 individuals per hectare, to a breeding pair per hectare. But I could very likely find that range is too large, that I'm actually not surveying a habitat that's so high quality I'm going to find 2, or so poor quality that I'm going to find 1 individual per hectare. But let's just start with the high end, because that's often the most likely. You're not reaching that maximum point. Say that I go out and conduct a bunch of surveys, and really I'm finding about 1.8 individuals per hectare. Their territory sizes are a bit larger than what we would say the optimum would be. And I keep my power at 0.9. And as you can see now, my sampling to find that difference has to be 120. So 40 surveys in each habitat. So thinking about sort of a best and worst case scenario can be really useful when you're starting a project. Now, if I see this at the onset, I'm going to know that 120 point count surveys, that actually takes quite a lot of time to conduct those. And because you have to space them out, you have to set them up, you have to do some time surveys, you have to do them in the morning, so you're limited by the time that you have during the day to do them. You can't do them all day long. So that's going to be something that I'm going to think, okay, can I actually get that done in 2 weeks? And yeah, probably. I'm just going to get up really early and do all this. But if it seems unrealistic, if I start to get numbers that seem really unrealistic, then you need to think about how you would restructure that study or change the question somewhat so that you would be able to collect enough samples. That's what we're using this for, to give you this idea. And also to help you start to structure a research plan. Doing bird surveys in 3 habitats is going to take some planning to make sure you're doing your sampling with your replication and collecting enough sample sizes. And so I would, from this information, think, okay, I actually don't really know if 120 surveys in a period of 2 weeks is enough time. Let me look at my schedule between the hours of about 5:30 in the morning till about 8:30 in the morning. I can probably get X number of surveys in, and how many days can I do that for realistically? And maybe you can go beyond that and you get lucky, but some days you might even get rained out. And so that's where this can be really helpful to get you started to planning your project. Okay.